Let's talk about linear combination, which is another algebraic technique to solve systems of equations. Another term for it is elimination, and those terms will be used interchangeably. They both mean the same method. What we're going to do is we're going to take this system of equations and we're going to try to eliminate one of the variables. Because as you can see, we have two equations and two unknowns, and I'd really like to have just one equation with one unknown. So for starters, I'm hoping you're noticing that these two y's, these y's have the same coefficient. And so I'm kind of eager to line those up. And so what I'm going to do is rewrite these, and I like to rewrite them over to the side. And what I need to do is I need to line up your x's, your y's, and your equal signs. Some people say that you need to have them in standard form. Standard form is ax plus by equals c. You don't have to have the x's come first, but one thing that's for sure is you need to have your x's, your y's, and your equal signs lined up. So I'm going to rearrange this equation, and I'm going to check my equal signs are lined up, my x's are lined up, my y's are lined up. Cool. Now I can proceed. What I'm going to do is I want to eliminate one of my variables. Now, the easier one is going to be my y values. So would I add these equations or would I subtract them? Because I want to eliminate the y values. So I would want the 2y to subtract another 2y. So I'm going to subtract these two equations. Is that legal? Great question. Let's look at this. Here I have truth. I also have truth here. If I add these, do I maintain truth? I would get 17 plus 0, and I'd get 17. Cool. That's great. If I subtract them, would I maintain truth? So 3 plus, now be careful, 3 minus a negative 3. I'm going to have sort of a thought bubble here. This is really 3 minus a negative 3. So that's really 6. And this, my thought bubble here, is 13 minus 4. So that should be a 9. So do I maintain truth? 3 plus 6 is 9. Yes. So I'm allowed to add or subtract equations, which seems bizarre, but it's super handy. So I'm allowed to just go ahead and subtract these equations. I need to be really careful of my subtraction. I need to think, okay, 2y minus 2y, that's going to be a 0 or 0y. Cool. I really encourage you guys to create your thought bubbles here, because what you have is a negative 3x minus an x. I have found that with teaching 8th grade students, when you have this and you have to have your I remember its subtraction and then remember this diagonal viewpoint is just hard for you. That's why I encourage you to write it out. So we would get 4x, we would get 4x, and then we need to do 9 minus 7, we get 2. So we have 4x equals 2, so x equals 1/2. Now x equals 1/2. Now just pause for a second. I'd like to show you, if you're hating this subtraction issue, then we have another option. If you hate subtraction, don't worry, we can do addition. And here's how. I would like one of these to be the inverse. I would like to add these, but right now if I add them, I'd get 4y. So I'm going to make this equation a negative, or I'm going to multiply by a -1. So this would become a negative, this would become a positive, and this would become a negative. I'm simply multiplying everything by a -1. And so now I can add the -2y plus a 2y, I'd just get 0. 3x plus an x gives me 4x, and -9 plus 7 gives me a -2. So x is going to equal -2 over 4, or -1/2. Now hold on, before I thought my x was equal to 1/2. So negative 3x minus x is going to give me a negative 4x. The 9 minus 7 will give me a 2. So x is going to be equal to 2 over a negative 4, or a negative 1/2. So I have x equals negative 1/2. Now I need to figure out what y is. So what I'm going to do is plug my x value in to one of these equations. I'm going to choose this one because I don't feel like multiplying it by 3. So I have x plus 2y equals 7. I'm going to plug in my x value, so negative 1/2 plus 2y equals 7. I'm going to add a half to both sides, so 2y equals 7.5. Now I need to divide both sides by 2. So y equals 7.5 divided by 2. Ugh, what is that? Well, you need to figure it out. You cannot leave it like that. You cannot have a fraction within a fraction. So I have 7.5 divided by 2. So I could think of that as 15 halves divided by 2, or 15 halves times 1/2. So I'll get 15/4. So y is going to be 15/4. So my solution is going to be negative 1/2 and 15/4. You will notice this would be unfortunate to graph because I would not have my lines crossing at a perfect integral value because these are not integers. So I would have to guess, and I don't think I would accurately guess that this was, 4 3/4. You should always check. So my original equations are 3y minus 3x equals 9, x plus 2y equals 7. Use your original equations so that just in case when you manipulated them you made an error, you want to use the originals. So I need to make sure that 2 times 15/4 minus 3 times negative 1/2 actually equals 9. And if I do negative 1/2 plus 2 times 15/4, does that actually equal a 7? So take the time to do that and make sure it checks. That didn't take too long. That really didn't take too long either. So this is my answer. y minus 5x equals 16. 10x plus 7y equals 22. I'm going to start by rewriting these so my x's, y's, and equal signs line up. Now I need to figure out, I want to eliminate a variable, but I'm not seeing any coefficients that match up. The 2y and the 7y, I can't add or subtract those. The negative 5x and the 10x, I can't add or subtract those, but I do recognize that if I just multiplied the top equation by something, I could get my coefficients for my x values to be inverses. If I multiplied this top equation by 2, then I would get a negative 10x plus 4y equals 32. Please make sure you do it to all 3 parts. Now this equation here is just going to stay the same. Now if I add these, I'm going to eliminate my x's, so I will get 11y equals 54. So y is going to be 54/11. So y is 54/11. So now I have to find out what x is, and that takes some work. I'm going to take my first equation. I could take either, but I'm going to take the first one. So 2 times 54/11 minus 5x equals 16. That doesn't cancel. That's a bummer. 108/11 minus 5x equals 16. I'm going to subtract 108/11 from both sides. Ugh. Now I have to figure out what is the the common denominator for 16 over 1 minus 108 over 11, so that's going to be, I'm going to have to turn my 16 into 11ths, so I'm going to multiply 16 times 11, so 16 is the same thing as 176 over 11. That's equal to negative 5x. Notice there's nothing wrong with doing your work to the side. Don't do this in your head and get it wrong. Please just show your work. There's nothing wrong with that. You don't have to be able to do this in your head. Okay, so negative 5x equals 68 11ths. Now I'm going to divide everything by a negative 5, or in this case, it'll be more helpful to multiply everything by 1 over negative 5. So x is going to be equal to 68 over negative 55, or negative 68 55ths. As you can see, friends, we are no longer in the land of nice, friendly answers. Sometimes we get fractions. And now you would have to plug in your x value and your y value into both equations to make sure it checks. I'm not going to make you do that here, but that would be the right thing to do if you really wanted to get a full credit. For starters, we're looking at 3x equals 6y plus 12, 2x plus 5y equals negative 1. There's a couple options here. It's pretty cool. First, we'd want to line up our x and y values. Now we can proceed. Some people might notice that you could multiply the top by 5 and the bottom by 6. That would make your y's match or be inverses of one another. And then you could eliminate your y's by adding. You could also approach this differently. You could also multiply the top by 2 and the bottom by 3. That would give you the ability to subtract and eliminate the x values. Or maybe you would rather multiply the bottom by a negative 3, in which case you get a negative 6x plus a negative 15y plus a positive 3. And then you would add these equations, which is often much simpler than subtracting. It creates fewer errors. An additional approach, you might notice that all of these are divisible by 3. So could I just multiply one equation by 2/3? Why would I want to do that? Well, it's going to divide all of these by 3, but then I do need my x to match this 2x. So I would get a 2x minus 4y equals 8, and 2x plus 5y equals a negative 1. So now I would have to subtract to eliminate my 2x's. So be careful, negative 4y minus a 5y, that'll give me a negative 9y. 8 minus a negative 1 will give me a 9. So y is going to be equal to negative 1. Any of those approaches should lead you to the correct answer. If I get y is equal to negative 1, then I'll plug in to one of my equations. It doesn't matter. Regardless of the method you take, if you do things correctly, your solution should be 2, negative 1. Let's show that you can check that quite quickly. So 3 times 2 is 6. Is it 6 times a negative 1? That's negative 6 plus 12. Is that true? Yes. 2 times 2 is 4, plus 5 times a negative 1 is a negative 5. Does that give me a negative 1? Yes. So this is my correct solution. Sometimes things are just hard and you have to multiply both equations to get a coefficient that matches. First, I'm going to set everything up so that the x's, y's, and equal signs line up. I'm going to choose to write everything actually in standard form, with the x's coming first, the y's coming second, and then the constants being to the right of the equal sign. I have two options. I could multiply the top by 5 and the bottom by 2, or I could multiply the top by 7 and the bottom by 3. Depending on which approach I take, it'll either eliminate x or y. It doesn't matter. I'll still end up at the right place. I kind of like the idea of multiplying by a 2 and a 5 because I like tens. So I'm going to focus on multiplying the top by 5, so I'll get a 10y, and the bottom by 2, and I'll get another 10y. Although I'm going to make my life easier, and I'm going to end up adding, so I'm going to multiply this by a negative 2. So first I'm going to go through and multiply the 5. Then I'm going to go through and multiply everything by a negative 2. Now, because my 10y's are inverses of one another, I just go ahead and add. So I'll get an x plus a 0 equals 35 plus a negative 20, so that's a 15. That was sweet, just popped out. X equals 15. Awesome, I'll take it. So if x is 15, then what's y? So I can plug it into either of my equations. Go ahead and find out y. You should get that y is negative 19. So my solution to this system of equations is 15, negative 19.